Okay, we have a request for number 27 out of 1.4. It's about a free fall, goes like this. An object is dropped from the top of a 100-meter tower. Its height above the ground after t seconds is 100 minus 4.9 t squared meters. How fast is it falling 2 seconds after it's dropped? So for a little visualization, we can maybe draw in our tower. Most towers don't lean like that. This tower is 100 meters tall, and we've got an object dropped off of this tower. Here's our object. Maybe it's a rock or a ball or a coin or something. And the position of that rock after t seconds is 100 minus 4.9 t squared. So we are interested in this point at what how fast is it falling after 2 seconds? So how fast talks about a velocity, and right after 2 seconds is an instantaneous velocity. So this is an instantaneous velocity question, and it's asking for the instantaneous velocity at time equals 2 seconds. So the way we're going to do this is with a limit, and it's going to be a limit as h goes to 0 of our function. So in this case, it's p. This is normally where we would plug in t plus h, but since our t is a 2, we can go 2 plus h minus p of 2, and this is all over h. Okay, so moving forward, we've got the limit as h goes to 0. If we plug in a 2 plus h, we have 100 minus 4.9 times 2 plus h. That's a squared, minus p of 2, that's going to be 100 minus 4.9 times a 2 squared, and then this is all over h. So we've got some stuff to simplify here. We've got still the limit as h goes to 0. This is 100 minus 4.9. 2 plus h quantity squared is 4 plus 4h plus h squared, and then minus 100 minus 4.9 times a 4. And then this is all over h. Okay, so that should be the most ugly looking line of work, and now things start to get cleaned up. So let's see. We've got 100. We're going to subtract 4.9 times 4. It's probably about time I get a calculator out to do some of these things. So let's see. A 4.9 times a 4 is 19.6. And then that would be minus 19.6h. And that would be minus 4.9h squared. And then this is minus 100. And then minus negative 4.9 times 4. So that's plus a 19.6. And then this is all over h. Okay, I think stuff starts to get a little bit nicer now. Here's 100 minus 100. That makes 0. Here's negative 9.6 plus 9.6. That makes 0. And then of the remaining two terms, negative 19.6h and minus 4.9h squared, I believe that we can factor out an h. So let's do that in the next step. The limit as h goes to 0 of h times negative 19.6 minus 4.9. There's still one h there, and this is all over h. So then this h and the one on the bottom can cancel, and the limit as h goes to 0, let's see, that's going to be negative 19.6 minus 4.9 times 0. So we have negative 19.6. Now let's label it correctly. What is how fast is the object falling? So this is a rate of change. Remember that the velocity is another way of saying rate of change. And so in this case, we are talking about meters and seconds. So this is negative 19.6 meters per second. So there's our answer. It's a velocity since we've given the negative sign in the front, and that's the direction. If the question were to ask you for just speed, then we would look at just 19.6 meters per second. This is velocity. And that answers the question. Hopefully that helped.